Hi students, so this is part 2 of chapter 1 in our Psych 218 class, Introduction to Statistics or Analysis of Behavioral Data. So last time we looked at the difference between population and parameter. We looked at the difference between variable and data. And we also looked at the difference between descriptive statistics and inferential statistics. And we went through some learning check questions that ask us about whether research studies use data from samples or whether we have systematic differences between groups when we just look at individual differences in sample data. So again, if you're up to this point, make sure you have reviewed your part 1 in chapter 1. And in your textbook, that would be chapters 1.1 and 1.2. So moving on then into part 2 in our video lectures and 1.3 in our textbook, if you got that going. And we're using the 9th edition. Although if you're using other textbooks, you can find the matching section in your chapter 1. So here we go, data structures and research methods. A lot of this stuff at this point is going to be familiar to you if you've already used or have taken Psych 217, your research methods class. So take a look at these terms if you're familiar with them, and if not, that's okay. Follow along and review with your sources. So the first thing we have are variables that we've already talked about, and there are different kinds of variables. First of all, we have individual variables. That means for each person or individual, the score changes depending on what we measure. And so, depending on whether we grab it from the population or sample for statistics and population for parameters, we use different data types that may require different statistics, and statistics here being different statistical procedures. And so one of the things that we have to take into consideration when we look at these variables is that, hey, what's the relationship between the variables that we're observing and measuring? Remember, for variables, we have independent variables, or IB, the variable that we change or manipulate, or DV, your dependent variable, dependent variables. So that's the one you count or measure. Again, for more information about independent variables and dependent variables, you can review or go to your research methods or Psych 101, 102 to review those things. And we will use these terms to talk about variables. So taking into consideration the types of variables we are observing and measuring, depending on the relationship between those variables, we will use different data structures in our research. So take a look here. We have different research methods that would need different data structures. So here's the first one. And you may be thinking of a different one, maybe experiment. That's coming up. But the first one we're going to look at is called the correlational research method. And you can take a moment, and if you already have, think about what the word correlation means. And yes, it has two variables, but we're looking at a particular relationship between those variables. And one thing about the correlation is that we have one sample, one group of participants, and we ask them two questions. We have two variables. It could be, for example, how tall are you, your height, and let's say how big your shoe is, your shoe size. Okay, so this could be variable 1, and this could be variable 2. I'm just using V1 and V2 for now. So we might think, for example, the taller a person is, the larger their feet tend to be. And so there might be a relationship that as a person grows taller and you find a taller person, their shoe size is probably going to be bigger. And so we can look at relationships like that between variables of the same group of people and figure out if there is some kind of relationship, whether the relationship goes in the same direction for both variables, or a relationship goes in opposite directions. So for example, maybe we have another set of variables like the temperature outside the room temperature, and let's say if it's a hot day. So if it's a hot day, would you consider buying a hot cup of coffee or a cold cup of coffee? So if I go hot coffee, and you can think here, as the temperature goes up, the hot coffee sales might go down. So as one variable goes up, the other one goes down. And if you remember the terms like positive correlation and negative correlation, and we use the R here, which we'll explore later in the course in chapter 14, then yeah, those are the types of relationship that we're talking about when we look at relationship between two variables from the same group of participants. One thing we want to emphasize here is that this type of correlational research is not experimental. We are only measuring the variables. We do not do anything to change them or manipulate or control them. We only measure or count them. So in a way, they're both dependent variables. So this would be height and shoe size. We don't change people's heights, and we don't change people's shoe size. We could sell them different shoes, but we don't change the person's shoe size. We could, that would make us, pretty interesting. The same with the temperature and hot coffee sales. This, if you're thinking about there are ways to change hot coffee sales and temperature, yeah, you're onto something, and we'll talk about that. But remember, correlational research is not experimental because we are not specifically and intentionally changing those variables, or at least one of them. So with this correlation, here's an example. In this correlational study, we look at, for example, when, let me see here, how much time does a person or student spend waking up, and how their academic performance is in relation to how much time they spend awake. So if you think about it this way, the more a person is awake, that means they have less sleep too. So as you can see here, it looks like, whether you're looking at the chart here or in the scatter plot, so this is called a scatter plot because the points are scattered. I only need one T here. As a person spends more time waking up, their academic performance seems to go lower. Or I should say it this way, as you find a person who has spent more time waking up, that person seems to do not as well in school. If you find a person who has fewer wake up time, maybe slept more, then that person seems to have done better in school. Notice this is a relationship between wake up time and academic performance, which will lead to our next point, which emphasizes the fact that correlational studies are not experimental studies. And here are some of the limitations that we're going to talk about in relation to this. Correlation studies, as you've seen from the last picture, only help us demonstrate whether there is a relationship between the variables. So if you see directional changes, for example, as one spends more time waking up, a student, their academic performance seems to go lower. Or again, like I said before, if you happen to find a person who has spent more time waking up, that same person would appear to have a lower academic performance in terms of GPA. However, note that this does not explain why this relationship is happening, nor does it explain why these variables are related. We can only describe what we see. We can't say why, because we haven't demonstrated something called cause and effect. We haven't actually changed for the same people, like make them sleep more or less and see if they do better or worse. We only measure them in a moment in time, like a snapshot, taking a picture of somebody, but we haven't actually asked them to do anything. We only ask them how much they slept or how much they spend waking up and what their GPA is at that time. Therefore, we cannot exclude other things that might influence what they tell us. For example, the person who has spent more time awake might be working, or the person who has spent more time sleeping or not awake could be doing other things, or that person might not be reporting, and there could be individual differences. So these would be confounding variables. Again, terms like cause and effect, confounding variables, would be terms that might refresh your memory if you have taken a Psych 217 or go think back to your Psych 101, 102 class. So before we go on to this comparison between groups, one thing that you might remember, and I'll write it down for you, is this: correlation does not equal or does not necessarily equal to causation, because we have not actually done any manipulation whatsoever. We only measured both variables, so we cannot say anything about whether one variable causes another, whether height causes a person to have larger shoe size. You can find somebody who is tall but have maybe size 6 feet, and maybe you can find somebody who is short, maybe 5 feet tall, and have size 12 feet. It is possible. So there could be third factors involved in cases like this. So again, correlation does not necessarily equal causation. The next comparison we can make is not just to see if there's a relationship between the groups or variables. We are actually having multiple groups. This is why in the next section we have comparison between groups. In correlation, we only look at one group and see how they respond to two variables. In a comparison between groups, we have two or more groups of people, but we're asking each group the same question. And if we have an independent variable, we make one change for everybody. So this is where if you have an independent variable, you can have one group that, for example, maybe you, this is in this statistics class, maybe some of you use a textbook. So maybe one group uses the textbook and then another group does not. No text. And maybe if, we're all taking the same class, but some use the textbook and others don't use the textbook. It does happen. I remember when I was doing the Writing and Learning Center and I asked a student in week 6 who was coming for help, have you opened your textbook yet? And that student said, no. And the student said, I asked him why, and he goes, oh, the textbook's too expensive. Another student showed me the textbook, but it's still in shrink wrap. So it is possible, but just for the sake of this example, two variables. The independent variable could be whether the person used a text or no text. And then the dependent variable could be your grade. Okay. So for each participant in both groups, we have group 1 here, people that use the text, and group 2 here, people that haven't used the textbook or don't. And we ask, we'll see how they do in the class by recording their grade. And the grade that we record is the dependent variable, the variable we measure. And the text or no text, group 1 and group 2, would be your independent variable. Note here, when we compare groups, we can do this in an experimental way where we deliberately make the change. Or we do this in a non-experimental way where we just get the people who happen to use the textbook and those who happen to not use the textbook. So here's what we mean. In a non-experimental research, this would be like, oh, I just ask each of you, like maybe in week 5 in this class, and I just ask only whether you use the textbook or not. And some of you will say yes, some of you will probably say no, and then I'll have two groups. So I only ask. So no manipulation. I don't make you use a textbook. I don't make you not use a textbook. In an experimental one, I would actually act on this. And I would actually say, okay, I'm going to randomly assign each student, maybe 1212 or something, or a random number generator. And then I would actually make each person, and if you agree, would follow along and go, okay, I'm going to use a textbook this term, or I'm going to not use a textbook this term. And so there is some type of manipulation. Now, if you're thinking, oh, this might not be ethical, yeah, you're absolutely right. I can't do that. So there are cases where the experimenter can randomly and deliberately assign people into groups. You can think of medical treatments here. Again, you can question the ethics of that, or assign tutoring groups randomly, or I can just ask and figure out the groups as the students respond. But comparison between groups happens, and we can start inferring cause and effect relationships because we are comparing different groups. So here's what that would look like in terms of a graph, a picturesque example. So here you see parental discretion advice, I suppose, talks about violence. We're comparing two groups here. Whether somebody has watched a violent film or show, and we measure what kind of behavior they exhibit after watching the show. So here you see there's a group of people that have happened to have watched the violent TV show or movie or film, and then another group of people, they haven't watched that. So here you can see, if you count quickly, oh, there are 9 people per group, but these are all different people. So there's a group of 9 over here, call this N1, and then there's another group of 9 other people who have not watched the show. And we're comparing these groups to see if there is a difference in aggressive behavior that the people show. Whether, let's say, the people who have watched the violent show or demonstrate more violent behavior. And if you look at the scores quickly, yeah, they seem to have that. Like the violent group has, more 4s and 3s, and the non-violent group doesn't have any 4s at all. It's only 1 3, and most of the scores are much lower. So if you know anything about like calculating averages and mean and looking at total scores and even beyond, like standard deviation and variance, yeah, you can start making those comparisons. And even just looking at the data, you can see comparisons already. And the last method, in terms of experimental control, where the researcher controls the environment, the situation as much as they can, is the experiment way. And this works to demonstrate a cause and effect relationship between the variables. And the experimenter can do this because they're the ones making the change. Remember, in correlation, no change has been made. When you compare between groups, you can either make the people go into different groups or just observe the groups as they occur. In an experimental method, you are making the change and you are assigning the groups. So when you do that, because you have made the changes, you can start to demonstrate and test a cause and effect relationship between two variables between groups. And we do this by manipulating the independent variable. So like we said in the last slide, if I, as a teacher, were to actually make you use a textbook or not, I would do that. I would be manipulating the independent variable, in this case, whether a person or student uses a textbook. Again, the ethics would not agree with this, and neither would I, but the action is the manipulation. And then we measure the independent variable for everybody. And in this case, it would be your GPA or your grade for this class. And you can take a moment at this point and figure out your own experiment. You might do this for Psych 217 anyway in the future. If you're taking it this term, then yeah, use this as a thought experiment right now if you can. And while we do this, we are also controlling all other variables. We try to control for individual differences, and we try to make the environment the same for everybody. So for example, if we're doing this class and I happen to quote unquote make students use textbooks or not, I would give each student the same test. I would put each student in the same time slot, and I would use the same system to grade everybody, so then everything else is fair and controlled. And so here is a example. Here's an example of an experiment, and this is what the data structure would look like. Here we see the independent variable, whether a person, is counting money or is counting blank paper. And we have the pain rating when you're actually doing the motion of lifting the paper and counting paper, and what that person says about how painful the activity or exercise is. It would appear that if the group that were told that they're counting money, they would report less pain than they were counting paper. You can think about the reasons for this, but again, focus on the structure. The one group has been told to count money, or they're actually counting money, which is paper. Well, let's just say it's paper. We do have plastic bills in Canada and other places, but let's just pretend in this experiment that they're using paper bills. And then in the other group, they're just counting pieces of paper. And in this experiment, it would appear that those who have been made to count pieces of paper would report more pain. Perhaps you might think as one explanation is that, well, they're counting money, and money, does make people happy for a number of reasons, so they might forget about the pain and report less pain. So that's one possible explanation. But again, because there is manipulation, you are making one group or both groups of people do something. You can start to test and demonstrate cause and effect if there is. So to review, if you don't know this already, here's the last chance for review. If you know your PSYC 217, you would know this already. That's great. If you know your PSYC 101, 102, you would also know that, which is also good. Independent variables are the ones that you would manipulate or change or control. And this is the only variable that the experimenter would actually change or manipulate, controlling all other variables. And that way we can start testing and demonstrating cause and effect. And dependent variable is the one that you measure to see if there is an effect between groups. So again, you might think of words like independent variable as the one that you manipulate, okay, or change, okay, and the dependent variable is the one that you measure or count. If those help you remember, good. So in addition, when it comes to the experimental method, we have experimental control. And what we mean here is to control the environment, control the situation that the participants are in, so then we can say with more confidence and certainty that there is a cause and effect. So here are some things. We want to make sure that our sample is randomly selected, and we want to make sure that these samples, these groups of people, these participants, are assigned in conditions based on an equal chance of each participant being placed into either group or any group. By doing this, we're not choosing people to be in the sample because, for example, we like them or don't like them, and we don't place them into groups by any other means except some sort of fair or random means. So then we can have a sample and the groups being more representative than the population. So this is how the random works. So in a way, to remember, this random assignment, random selection, and random assignment. So assignment is for groups, and random selection is for the sample. And these help us make a better representation of the population. So then we can also use inferential statistics. as well as descriptive statistics. To do this, we can match participants and to groups, again using random assignment, and we would want to make sure that the researchers don't know how they're assigning the groups. Again, we want to leave it to a sort of system, whether it's a random number generator or some random assignment method. Single blind means that the participants don't know which group they're in. And this is very important because there is something called a demand characteristic. That means, for example, if participants know that they're in an experiment and they know what group they're in, they might act the way they think they're supposed to. For example, if you talk to a police officer and you want to be a good citizen, you might want to be helpful. But let's say if you talk to somebody who isn't a police officer and you don't know that person is a police officer, you would not talk the same way as you would if you know you were talking to someone who is a police officer. That is called a demand characteristic because, in situations like that, you would act in a way that might be demanded of you or expected of you. In double blind, not only the participant doesn't know which group they're in, the experimenter, or at least the researcher who's assigning the groups, don't know what each participant is in either. And this is another factor to eliminate things like unfair measurement, because, for example, if for me, for example, I happen to know which group of student or which student was using a textbook and which students don't, I very naturally would have a bias against students that don't use the textbook. I would think they're not going to do well. Not only would they not be following instructions, but they're doing themselves a disservice because they're not using the resources they have. And if I knew that and kept going with the experiment, it would not be fair for me or for the experiment or for you either, because I'm already partial to it. So again, single blind is participant only, that doesn't know what's going on or which group they're in. And double blind is both the experimenter and participant. They don't know what group they're in. And finally, of course, we want to control all other confounding variables. So again, in our case, it could be same time, same tests, same grading systems, same grade rubrics. So then we can say with more certainty that, yeah, it's because the student has a textbook or not. Okay. Conditions that we can place participants in. Experimental will be the one with the change. Again, that's another word for that is the treatment condition. If you have a group with no change, like for example, if everybody starts out with no textbook and we leave that as it is, then it would be a control group because we didn't do anything. We gave them no treatment. Or if it was a test for a drug, we would give the control group no drug or give them a fake drug, which is called a placebo, like a sugar pill or something, and tell them, oh yeah, that's a pill that will improve your memory, or that's a pill that would help you relax, or that's a pill that will keep you awake. And then that way we can compare both groups, the experiment group or the control group. So there are non-experimental methods as well, and we'll go over these in brief. Again, you can learn more about this in your research methods class. So there are non-equivalent groups where, yes, we're still comparing groups, but we can't control which participant goes in which groups. So it would be like, for example, naturally, if I were to ask whether you guys use a textbook or not, and you guys have made your choice, but we can't really control you. I can't make you go use a textbook or don't use a textbook. I can strongly encourage you to use a textbook, but it's still your choice. Another group is Pretest-Posttest. That's another method that is non-experimental. I can test you once at the beginning of the class and then say, oh, this is how much you know about this chapter. And then I can test you again at the end of the class today. Like, if it was a 5 to 9 class, I could test you in a pretest of 5 p.m. and then I could test you again at 9 p.m. to see how much you've learned over this time. And again, while I'm teaching, for example, I'll be teaching everyone, but I cannot control what happens for you, for each individual at the particular time and between 5 to 9. I can't. But it would be a pretest post-test. And one more here for this chapter, we can talk about a quasi-experiment where a researcher would assign people into groups that is sort of independent but not. Again, I can't control for this. It could be I could be matching your last names, making random groups based on last names or whatever in alphabetical order, but that would not be random and that would not be the same, and I'm not actually making any control per se other than just some sort of assignment that's more or less arbitrary. So here's another learning check. And this one is more focused on research methods, which is still a foundation for behavioral data that we're analyzing. So here we go. First question, or question 3 rather. Researchers observed that students' exam scores are higher or were higher when they had more sleep the night before. This study is a descriptive study, experimental comparison between groups, a non-experimental group comparison, or a correlational study. Take a moment and review your different types of research methods and see. So if you have chosen a correlation study, you would be correct here because we have only observed. Again, reading the question and checking the wording would be useful. Notice here that the researchers only observed. They did not make the participants do anything. Second, they only looked at one group, just the students. And for each person in the group, they had 2 variables, exam scores and sleep. And remember, if there's only one group and the researcher hasn't done anything, you can't say anything about whether sleeping more or less causes the exam scores to go higher or lower. So this would be a correlation study. Here's the last one for this part. Okay, so question 4 has 2 true-false questions. A, all research methods have an independent variable, true or false? And B, all research methods can show cause and effect relationships. Again, take a moment and think about the different types of variables. And if you remember, depending on the variables that you have, you would have different research methods. And vice versa, different research methods would have different types of variables. See if A is true, and think about the relationships between the variables and whether every single research method would show a cause and effect relationship. And if you answered false for both of these, you would be right, because for A, a correlation study does not have an independent variable. They only measure, so they're both dependent variables. And for B, only the experiment method controls the influence of the participants and the environmental variables, and only that type of research study can show and test a cause and effect relationship between 2 or more variables, and usually it's 2 to keep things simple. So that's it for our part 2 of this, and we will continue in part 3 with the last part on different ways of defining variables in terms of scale and measuring them. So stay tuned for that. Again, review parts 1 and 2 of chapter 1 in these videos. Again, the first chapter would have more concepts as we transition from concept to math. And stay on top of things. You can practice, ask me questions via email or on the discussion board. I'll see you in the next one.